Hello everyone. This video is on the Knewton Alta assignment for section 5.2 called Solving Systems of Linear Equations by Substitution. So in this video I'm going to be going over a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are all the same, the structure should be similar, so I'm hoping that watching me do these here will help you in some way when you work on the assignment on your own. Now when you're on the assignment page, you should see the title, the mastery bar telling you how far along you've gotten, the objectives. Hey, only one objective, so this should be a bit of a shorter video. And then under the current objective, you should see a question related to that objective. And at the bottom of every question, you should be seeing a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button. It's for instructors only. You will have a more instruction button. If you're ever struggling with a topic or a question, try clicking on this and you'll be taken to a page with some reading or some videos to study. And then you'll be given questions related to that instruction, and completing those questions will progress you through the assignment. Alright, so the only objective here is solve a system of linear equations by substitution. Now you may recall that in section 5.1 we were solving systems of linear equations, right? Two linear equations with two variables, graphs of two lines, and we were solving them by graphing. And if you recall from section 5.1, you graphed both lines and then you tried to figure out where they crossed. Right? What was the point of intersection? That was the solution of the system. Right? A solution of a system is any ordered pair that satisfies both equations or all the equations of the system. Alright, well, we'll get back to graphs, but for right now we're going to be solving these things without graphing. We're going to actually be able to find the ordered pair, the point where they cross, without graphing. Alright, so here's how. Alright, so I'm going to write this first system up. So we're given these two lines, y equals negative 2x minus 2, and the other one is 7x plus 3y equals negative 9. Okay. Now I'm going to write substitution over here, and we'll go through the steps. So the first step is solve one of the equations for one of the variables. Solve one of the equations for one of the variables. Just pick one. Now that's already done here for us, right? We don't have to do much because you see how the first equation, the top equation, is already solved for y, right? Y is already by itself, so I got that. Done. Done with step one. Now here comes the substitution part. Substitute into the other equation. Into the other equation. Right, so you see how I have y equals negative 2x plus 2, or sorry, minus 2. So this negative 2x minus 2 expression is the same as y, can replace y wherever you see y in this system. Right? For any ordered pair that satisfies all the equations, these relationships should hold. So I can replace y with negative 2x minus 2 in the other equation. So you see the other equation, there's y. I'm going to replace that y in the other equation with negative 2x minus 2. So that gives me 7x plus 3 times, and then anytime you replace something, put parentheses. It'll make it a lot easier for you, I promise. So 3 times y becomes 3 times this expression, the quantity negative 2x minus 2. And then we have equals negative 9, right? So this is that second equation where y has been replaced by negative 2x minus 2. Next step is solve the resulting equation. All right, so I'm going to solve, see after I replace y with negative 2x minus 2, that second equation, instead of having two variables, now just has one variable. Right, and I can solve for that one variable. So distributing the 3 here, I'll have 7x, and then 3 times negative 2x would be minus 6x. 3 times negative 2 is minus 6 equals negative 9, and then you have just x minus 6 equals negative 9, then adding 6, x equals negative 3. Now this is only half the answer. Right? This is only the x value of the solution. Remember, the solution of the system is going to be an ordered pair, an x value and a y value. This is only the x value of the solution. All right, then, take this value and substitute it back into some equation with x and y and solve for y. So now I substitute this value into an equation with the other variable and solve. So substitute this value into an equation with the other variable and solve. So x equals negative 3. Here's an equation with y in it. And I'll replace x with negative 3 and solve for y. So we have y equals, instead of negative 2 times x, it'll be negative 2 times negative 3 minus 2. Y equals 6 minus 2 is 4. And there's the y value of the solution. And now we're done, right? There was only x's and y's in this system. So the solution of this system is the ordered pair, remember x coordinate first. So x was negative 3, comma, y coordinate second, 4. And you should always check your solutions. Just make sure that that's a solution of the system. So replace x with negative 3 and y with 4. 4 equals negative 2 times negative 3 minus 2. Yeah, you'd have 4 equals 4. And then 7 times negative 3 is negative 21. 3 times 4 is 12. Negative 21 plus 12 would be negative 9. So this does work. It does satisfy both equations. And now you could also check, by graphing. Right, going back to section 5.1, how we solve these things by graphing. Now you can make it really easy on yourself and just go to that graphing calculator website, desmos.com, free online graphing calculator. And I'm just going to enter the equations we were given. Y equals negative 2x plus minus 2. There's the graph of that line. And 7x plus 3y equals negative 9. And there's the graph of that line. And you can see that they cross here, right? See, they cross here at the point negative 3, 4. All right. You can see where they cross, negative 3, 4. And that's exactly what I had after solving by substitution. Right? Negative 3 for x, 4 for y. And that's what we're putting here, right? The ordered pair back in the assignment, parentheses, negative 3, comma 4. Right? The point where they cross, the point of intersection, the solution of the system. Now after you submit an answer, Now, you'll be told if you're right or wrong, and then be given some sort of answer explanation. Please read through the answer explanations just to make sure you understand why something was right or wrong, and then hopefully you can use that and learn from your mistakes for future questions. All right. Same thing. Given a system of equations, asked to solve using this substitution method. All right. So once again, I'll write this out. And I'm not going to write the steps out in words. I'm just going to say them. So here we have x equals y minus 2. And the next equation in the system is negative 5 times x plus 3 times y equals 8. Alright, so it's already set up nicely where I don't have to do anything. The first step was solve one of the equations for one of the variables. The first equation is already solved for x. So now I can take this expression here, this y minus 2, and replace x with it in the other equation. Right? Because x is equal to y minus 2 in this system. So now the other equation becomes, let's say becomes, after the substitution, instead of negative 5 times x, now it's negative 5 times this expression, y minus 2. Right? And don't forget the parentheses around that. Then we got plus 3y equals 8. Then I solve this new equation for y. Right? Distribute the negative 5 here. You got negative 5y plus 10 plus 3y equals 8. Negative 5y and 3y make negative 2y, and subtracting 10 from both sides will give me negative 2 on the other side. Dividing by negative 2, I get y equals 1. Alright, and again, this is only half the answer. That's only the y value of the solution. And then I just put this back, and for y up here, we get x equals 1 minus 2. 1 minus 2 is negative 1. There's the x value. So the solution of this system, the point where they'll meet, is negative 1 for x, comma, 1 for y. Alright, and then double check, replace x with negative 1 and y with 1 in both equations, right? And it should make both equations true, and it does. Or you could go to a graph. Alright, let's do the same thing I did in the last problem. Make a graph of these two. X equals y minus 2. There's a graph of that line. Negative 5x plus 3y equals 8. And you can see where they cross right here at negative 1, 1, which is what I had. Alright, so I'm entering the ordered pair, negative 1, comma 1. Great. Alright, and then the next question should be more of the same. So once again, it's already set up nicely where one of the equations is already solved for one of the variables, right? The first equation is solved for x. Alright, so here's the system. X equals negative 4 times y plus 6. Second equation is 2x plus 3y equals negative 3. So yeah, I'm going to take this negative 4y plus 6 and replace x, right, because that's what it's equal to. It's equal to x. I'm going to replace x in the other equation. So now this equation becomes 2 times, instead of x, I put the quantity negative 4y plus 6, and then you still have the rest of it, right, plus 3y equals negative 3. And I solve this equation for y. Alright, distributing the 2 here, you have negative 8y plus 12 plus 3y equals negative 3. And negative 8y and 3y make negative 5y. And then if I was subtracting 12 from both sides, you'd have negative 15 over here, and then dividing both sides by negative 5, y equals positive 3. And then if I put this back into the equation with x up top, we have x equals negative 4 times positive 3 plus 6 That's negative 12 plus 6. That's negative 6. Right, so negative 6 for the x-coordinate, 3 for the y-coordinate. There's the solution. Negative 6 comma 3. Right, there's the solution of that system. And you can double check, replace x with negative 6 and y with positive 3 in both equations, and both equations should be satisfied. Or let's just double check on the graph, by graphing. Why not? So x equals negative 4y plus 6 was the first equation. There's that line. 2x plus 3y equals negative 3. And you can see where they meet, right? Negative 6, 3, which is exactly what I had. Excellent. All right, so I'm entering the ordered pair, negative 6 for x, comma 3 for y. Submit, and wonderful. And there should just be one more of these. Hopefully this isn't so bad. All right, one more, and it's very, very similar, right? All these are pretty similar stuff. Pretty similar problems, solving a system by substitution. And once again, it's set up in a nice way where one of the equations is already solved for x again. So I have x equals negative y minus 9 for the first equation. Second equation is 5x minus 6y equals negative 1. And I see negative y minus 9. That's equal to x, so that expression can replace x in the other equation. That turns this other equation into 5 times the quantity negative y minus 9, then minus 6y equals negative 1. I solve this for y. So I distribute the 5 here. We have negative 5y, then minus 45, minus 6y equals negative 1. Negative 5y and negative 6y make negative 11y. I would add 45 to both sides to get 44 on the right, and then dividing by negative 11, y would be negative 4. And then I pop negative 4 into any equation with x, but I'll just do the first one since it's solved for x, right? X equals the opposite of negative 4 minus 9, which is just 4 minus 9, which is negative 5. So the solution is negative 5 for x, comma, negative 4 for y. That point is where the two lines will cross. And let's just be doubly sure, absolutely certain. I'm going to go to the graph. Desmos. X equals negative y minus 9. There's that line. And then 5x minus 6y equals negative 1. And you can see right away where they cross there at negative 5, negative 4, which is exactly what I had. Now, each one of these examples had one solution. Right? They had just one point where they crossed. We'll come across problems in the future, I'm sure. If not, just know that they're out there. What if the system had no solution? All right, if the system had no solution, if you tried solving it with substitution, you'd end up with some statement like 0 equals 1 or 1 equals 2. If you try to solve a system by substitution and you end up with some nonsensical statement, then the system has no solution. They're parallel lines. Now, if they're the same line, what if there are infinitely many solutions? Well, then you'll try solving the system by substitution, and you'll end up with a statement like 1 equals 1, or 2 equals 2, or 0 equals 0. You'll end up with an identity. So if that ever happens, then you know that the system has infinitely many solutions. All right, but for right now, I think in this first section here on this topic, you're going to be given problems where you're going to have one solution only. All right, and that should be it for this preview version of this assignment. Like I said at the top of the video, the questions I saw here may not be the same questions that you see, but the objectives are the same, the structure should be similar. So I'm hoping that watching me do these here help you in some way when you work on the assignment on your own. And thank you very much for watching.